All right, so my name's Aaron Phipps. I'm an assistant professor at the United States Military Academy, which many of us may not know, but that's West Point. When people say they teach at West Point, they mean United States Military Academy. And I just need to make it very clear that, of course, my views and the things I talk about here don't reflect the opinions of the Department of Defense or the Army or the United States Military Academy. These are strictly my own ideas. All right, so to get started though, today what we're going to be talking about is the unintended consequences of teacher performance pay. So one of the things I'm really interested in here is how we can think about personnel economics and contract theory applied to nonprofit sectors and people who may have some intrinsic motivation as opposed to a profit motivation. So, of course, if we're going to talk about teachers, it's important to begin by establishing that they matter. So this is just a chart from Raj Chetty et al. So Chetty, Friedman, and Rockoff have a series of really good papers establishing the fact that teachers do matter. And this is just the effects that standard deviation in teacher quality may have on your earnings, but they also have strong impacts on reducing teen pregnancy, incarceration, and a few other outcomes beyond just income. So given this sort of established literature that teachers matter, the next question is, do they matter enough relative to other inputs at schools? And that's another thing that's been fairly well established, that teachers themselves are probably the most important asset of schools. And one way to think about this that I like probably the most is sort of comparing the effect of improving your teacher quality to the effect of reducing the number of students in your classroom. And it turns out that a standard deviation increase in teacher quality is more effective or more impactful than reducing your class by 10 students. So if you think about costs of class size reductions versus costs of improving teacher quality, it seems to be an important tool or important point to improve the education quality. And of course, there's, like I said, there's several more papers here, but I just wanted to focus on establishing that they are an important component of the teaching production function. And not only are they important, there are also very big disparities in terms of the quality of teacher. So what we have here, and it's a little fuzzy, but these are, each bar represents a school district, and in the school districts, they just looked at the quality of the teachers relative to the quality of the teachers in schools that are mostly free and reduced price lunch versus the quality of teachers that are, sorry, I'm gonna mess with these cameras. So this is the difference in the quality of teachers for free and reduced price lunch students versus those in higher income schools, right? So you just take a school that has mostly low income students and you compare it to schools that have high income students, and they can show that there are very wide or very large differences in the quality of teacher based on the income of the school, okay? Or the income of the students at the school. And so, of course, this is a very important part of trying to think about policies for improving access to opportunity and equalizing that across different spectrums. So, given that teachers matter and that there are disparities in ways that we would like to avoid, right? We'd like to have equal opportunity regardless of your income. The question is, what do you do? Okay, and so of course there were these issues of, well, maybe we can retain and recruit better teachers, or we can motivate and support teachers to be better. And as you can see, there's a whole literature, very large literature on both of these things, both in economics and education psychology and all over the place, okay? But what I wanted to focus on is trying to just sort of streamline our idea into why economists are getting involved in this discussion in the first place. And so as you can see, of all of these first two are a lot about teaching teachers and how you educate them and train them, and then how you restrict access to becoming a teacher. It turns out both of these things, well, first of all, pre-service training doesn't seem to have very large effects. It's debatable. Licensing requirements seem to reduce the quality of teachers because it restricts access to a lot of teachers that may become good. And so these haven't been very effective policies. On the other hand, these are all the things that economists might be interested in, and these are the kinds of things that I'm interested in particular when we're thinking about personnel policies. So we have compensation, career potential, creating different trajectories for teachers who may not want to become principals. And then also even in-service training is an important part of what we're going to be talking about today as well. So again, this is why economists have gotten involved, and also why I'm particularly interested in looking at policies for improving compensation for teachers. So after all this, in the last decade especially, there's been a bit of a consensus formed that probably the best way we're going to improve teacher quality is to provide them with meaningful promotions, sizable pay raises that are earned as opposed to automatic. So in the last decade, we also experimented on this very widely. We had the $1.8 billion teacher incentive fund that awarded school districts grants in order to implement teacher incentives within their schools. The surprising result, and it's not surprising if you've looked at sort of the history of teacher performance pay, is that there are very, very mixed results. In some cases, it worked like gangbusters, and in other cases, it may have had negative effects. All right? So the results of these incentive programs are all over the place. And one of the problems of this is that in all of these studies, as we've tried to figure out how incentive programs for teachers work, they come in these very large packages of a whole slew of different qualities, right? So there's different programs, different ways that they're incentivized, and you can be incentivized based on the whole grade performance, the whole school performance, or on your own teacher performance, or on, right? Like, there's all these different dimensions that we can't actually tweak, all right? And so it's made it very difficult to figure out why some work and why some don't work. So today, one of the things that has received little attention in the education setting, but also sort of more broadly in nonprofit sectors is going to be monitoring. I shouldn't say nonprofits, but so one of these things that hasn't received a lot of attention, particularly in teaching, has been monitoring teachers. So there is a bit of a well-known exception to this, and that would be there's a study where they set up video cameras in classrooms. I believe it was in India. And they sort of watched to see if this would improve teacher quality, and it did, which is great. But in developed countries, and particularly in the US, the likelihood of putting video cameras in the classroom and leaving them there constantly is very small. I don't think that's ever going to happen. And frankly, I think the setting is different enough that it may not even be useful. But that's a different question. So I want to look at monitoring. And here's some sort of non-education monitoring where in a lot of the laboratory experiments when they're testing different types of incentive structures, monitoring was frequently and often the most effective incentive policy, and it was consistently so. And then in a field experiment, this is also somewhat popular, there was the self-reporting of, self-reporting like the kinds of calls you made or how frequently or how many calls you made. And they implemented this monitoring practice to show that monitoring did reduce unwanted behavior. Okay, so this is sort of the monitoring literature outside, and this is a very brief overview of it, outside of education. Inside of education, we don't have a lot of monitoring, but we do have stuff about teacher in-class observations. And so this paper, they looked at the effect of a very large program that just had people sit in on teachers' classrooms and observe them and then provide feedback, and then the next year they would see if the students did even better, right? And so they found that this sort of a program did seem to work, although these results are surprisingly not replicating very well in other settings. Another, probably the closest one we've come to actually seeing monitoring was a program implemented in the 70s, and the teachers did receive these unannounced visits, but the biggest problem is that the teachers were selected into the program. And the other problem is that in this study, they are unable to separate the monitoring effects, so the sort of incentive motivation effect of having the possibility of an evaluation. They can't separate that from the feedback effect, so the positive responses to this observation, right? Learning from the feedback you got. So And then, of course, I got to cite myself. But this paper just recently came out in EFP. And what we do there is we just show that teachers do change their pedagogical approaches as monitoring intensity grows. What we don't do in that paper is sort of what this paper is really focused on, is trying to understand how that might actually affect student outcomes. All right, somewhat of a long-winded intro, but now here we are with wanting to look at the effects of monitoring for teachers and see if it actually improves student outcomes. So the setting is the IMPACT program in Washington, D.C. I'm not sure if it's still, actually I think it is still called the IMPACT program. It's changed a little bit. They've gotten rid of a few things and changed a few others. But it started in the 2010-2011 school year. And it's just this very large incentive program where teachers receive bonuses and permanent pay increases based both on their student test scores for grades where students are tested and based on these unannounced in-class observations, so monitoring. And the setting is such that it provides random variation in when teachers actually were monitored or which days they were not monitored, okay? And so I'm going to use that random variation to see how having more monitored time affected student outcomes. But the other part of this is that I can also see how teachers change their pedagogy as monitoring becomes more intense and sort of relate that back to student outcomes. And then lastly, one thing I didn't list here, but the other important part is that I can see exactly when teachers received the feedback. So they had this conference, they'd sit down with their observer, and they'd learn what they'd done, and they'd receive feedback. And so I can actually observe that date, and as a result, actually control and separate out the effects of the feedback from the monitoring. And just to preview the results, I do find that monitoring improves student outcomes, but the effects are fairly concentrated in the few months leading up to standardized testing. And there's a variety of reasons why that might be, but certainly there is an effect from monitoring that changes teacher behavior and teacher outcomes. I can even show that teachers, again, especially right before the test, they start to really teach to the test when they think that they are less monitored, which also brings up some questions as to why being unmonitored would lead to lower test scores. All right, here's just a basic outline, but really I just want to point out that we're going to start by understanding how Washington, D.C.'s program worked, and then dig into a little bit how we specify the model, and then just show some of the results. All right, so as I said, this is Washington, D.C. Oops, I misspoke. It's the 2009 to 2010 school years when they started. So they started this program, and my sample is going to include only the 4th and 5th grades, and there's a lot of reasons why this is the case. The first is that the test-based incentive only exists for 4th grade through 8th grade. But in 6th, 7th, and 8th grade, there are some data problems in terms of the type of schools. So they had, some schools had teachers teach only a specific subject to all the students, and other schools would have teachers teaching all the subjects. And I can't actually observe that very well, especially since this is historical data. And so I'm just going to focus in on grades 4 and 5. So in my sample, there are 79 schools. There's about 4,000 students per year in this sample. And about 75% are black, 12% are Hispanic, and 65% of these students receive free and reduced price lunch. So this should be thought of as a fairly urban and also low-income setting. So this is the way that the incentive structure works. Teachers receive, they called it your impact score, but the score is comprised of basically 3 key ingredients. About 50%, or exactly 50% of that score is coming from your value added. So they look at how your students performed on their tests last year and compare it to how they performed this year and sort of create some measure of how much you contributed to their learning. So that's sort of that's a test-based part of this incentive. And then 40%, and in some years it was more, 40% is coming from these in-class observations. So teachers receive 5 of these unannounced in-class observations throughout the school year, and they receive very detailed feedback and very detailed scores, and that's going to go into calculating this impact score. The incentive structure itself is quite detailed, but the big things are, 1, if you do very, very poorly, you can be dismissed immediately. If you do poorly 2 years in a row, so they've got 4 different groups. If you're highly ineffective, that means you get dismissed. If you're just ineffective, that means you're on probation. So there's some negative consequences to that, like your pay won't go up the next year like it normally would. And if you're in that group again next year, you get fired. On the other hand, if you're highly effective, you get a big one-off bonus of about between $5,000 and $25,000. That depends on what kind of a school you're at. And then also, if you do that 2 years in a row, you get a permanent pay increase of up to $20,000 a year. So this is very, very large incentive. Yeah?
How large are those relative to just the base salary?
Base salary is about $60,000, $70,000. So big. Yeah. Yeah. Let me see. So as I said, there are 5 evaluations. I misspoke. Not all 5 are unannounced. So there are a couple things going on that make this complicated, but also interesting for my purposes. So first of all, 5 evaluations come from 2 different sources. One of those sources is going to be principals or administrators at your own school, and the second source is going to be an external evaluator, or what they call a master educator. So it's someone at the district level who is sent to your school to evaluate teachers. And they have these sort of overlapping windows. So you have 2 of these master educator evaluations that occur, and those are the windows that they have to happen in. Just as a side note, the first master educator evaluation was announced in the first year of the program, so I have to account for that in the specification. And then the first principal evaluation was always announced beforehand. Okay? But again, as you can see, that you have all these 5 windows, but they're overlapping in ways that open up opportunities for me to identify when teachers may have been unmonitored. Also, of course, notice that student tests are end of March, early April throughout the sample. So, just to help you understand how I'm going to measure unmonitored time. Sorry, one sec. It's easier to keep track of the time. So if we just had 2 evaluations and they occur in these windows one after the other, it's very easy to understand what an unmonitored time would be, right? You receive your evaluation, and then all the time afterwards is unmonitored until the next window begins, okay? All right, and so of course notice that I'm only going to count unmonitored time that occurs before student tests, okay? Now again, given the overlapping windows, this gets a little more complicated, because it has to be the case that you've received both of your possible evaluations before the start of the next window. So as I've shown, you've got window 1 here, so of course I don't care when the first principal evaluation occurs, because it's not monitoring, right? It's always announced ahead of time. So I'm interested in when that first master educator evaluation occurs, and if it occurs before the start of the second principal evaluation window, that's going to be unmonitored time. All right, so I'm going to repeat this process for all the possible sections. Yeah?
Were the evaluations randomized?
Not explicitly, but in effect, yes. So there's not a randomization component happening. Like they didn't have someone sit there and actually randomize it. But in the way that they were implemented, the spirit of the program was to make them unanticipated and also random. Now there could be some questions about whether or not they were correlated with student quality or teacher quality, and we'll get into that.
Like it says that the administrators might anticipate exactly this problem, and then if they know something about the quality of the teacher, they might delay.
Right, like you can imagine, yeah, I mean, that part, yeah, that'd take a lot of forethought on the principal side, to be honest. But yeah. So the best way to do this is going to be looking at a balance check, right, and see if we can actually observe any correlations between student or teacher quality and the timing of their evaluations. But certainly from the district side, that was, and again, it wasn't actually explicitly randomized, but there was no intent to systematically go about to certain teachers or target them. But yeah, I think it's going to be very important to make sure that while I can't, because of the lack of that explicit randomization, I'm just going to have to rely on the fact that the way these were implemented did not correlate with some of those unknown characteristics. So that's how we get to the unmonitored time. The other thing that's going to be important if we want to look at the effects of monitoring and, yeah?
Oh, sorry, so the last slide. So do the teachers know in advance, what's the criteria that they're going to be evaluated on?
Yeah. In fact, well, it's hard to show that on a display because it's a 9-bullet. So the evaluation it looks at 9 different components. And in each component, you get a grade of 1 through 5, and then they're going to add those up and average them out for each evaluation. But what's nice is that, of course, now I can see in the data, I can see exactly what you got on all 9 of those components. And that's actually how I'm going to look at how teachers changed their behavior, because I can see how they're shifting from one standard to a different standard as the probability grows. So yeah, they knew ahead of time both what they were going to be evaluated on. They received some basic training on like what they'd be looking for and how it was going to work. And then also they were made very aware of sort of the structure of the timing of the windows and when it was going to happen and how it was going to happen.
And so it's both content as well as, I guess, style, like how you do with students?
That's a great question. So the observation rubric itself is based on what's called the Danielson framework, but it's meant to be content agnostic, they'd say. So in other words, it doesn't matter if you're teaching math or science or English. It's meant to be more about your pedagogical approaches.
Right. So I guess there's probably going to be certain things that if I see, because I guess you can see the person coming into your class.
Right.
I might be nicer at inverted commas on the day that I see them, but it's going to be harder for me, I guess, adjust how I teach stuff. Right.
So if your lesson plan ahead of time was not very well suited to that evaluation, it's going to be hard to adjust on the fly, but not impossible, right? Like there's some things you could maybe adjust. Yeah, in fact, there was this concern about like a lesson in a box kind of thing, where like maybe teachers are sitting there with a lesson ready, and when the observer comes in, they're like, oh, never mind, you know. But that's more of an economist thought. In reality, they really don't do this. I spent a lot of time actually. That other paper that I cited earlier, that was the original purpose, was to see if maybe there's this process of teachers could actually just ignore the threat intensity because they could just be ready at any moment. It turns out not to be true, but also somewhat from a teacher's perspective, just not practicable, right? Like you can't do it. I wish. It's also funny. So my wife is an elementary school teacher as well. So she taught 2nd grade, and so throughout this whole project, I'm always asking her, like, would you actually be able to do this? No, that's stupid. All right. So as I said, we want to be able to estimate the probability of being observed, and this is just going to require 2 basic components. We need to know R, the number of remaining teachers at your school, and N, the number or the teacher's expectation of how many teachers to be evaluated. So this is a little complicated, right? Because I don't know exactly what teachers knew about who or how many teachers are going to be evaluated that day. Okay, so there are a couple things I can use. It turns out not to matter like much, which yeah. So it doesn't matter a whole lot. I can assume that teachers are going to expect there to be a uniform distribution of the evaluations. In other words, they would expect master educators and principals to spread out their evaluations evenly across the semester. That is actually mostly true for master educators. It is definitely 100% not true for principals who cluster all their evaluations at the end because they procrastinate. So the other way to do this would be to have like a kernel density estimate. So look at, create some sort of a kernel density estimate of the number of teachers being evaluated at your school that day, and then assign that to teachers, as in assuming that they had a rough sense of when the principal was roaming the halls or something. But like I said, it turns out not to matter much between those 2 different types of specifications, and I'm just going to stick, for the most part, with the uniform distribution. All right, so to build this up, what I want to start with, I've skipped over the theoretical portion of giving you a model of a teacher's best response to the probability of an evaluation, but it turns out that, as you'd expect, the bigger the threat or the bigger the probability of an evaluation, the basic model would suggest that teachers would prepare more for that evaluation. All right, they're going to exert more effort along the dimensions that matter most for that evaluation. So just so you understand what I have in mind, X can be sort of this vector of different types of teaching styles or approaches, right? So it'd be a vector of effort or tools and techniques. And then what we're going to do is we're going to start with the assumption that we have cumulative effects from each day of a teacher's teaching. So Y would be your effect on student test scores overall throughout the whole semester, and then you've got M monitored days and N unmonitored days. Y of x double prime is just your daily contribution on a monitored day, and y of x prime would be your daily contribution to a student's test performance on an unmonitored day. Now, to get into this y double prime, what I'm going to assume, and again, this is just for simplicity, but I'm going to assume that there's just this linear cumulative effect from probability. So in other words, there's this y bar, which is like a base daily productivity, given there's some non-zero chance of being observed. So y bar is, if there's any chance at all I'm going to be observed, I'm going to at least do y bar. And then as that probability grows, I'm going to increase my productivity by eta, right? And then I can also add linear feedback effects. So on these unmonitored days, what I want to do is make sure for all of the unmonitored days after I've received my feedback, I also want to add in this potential of improving my students' test scores by alpha, or y naught plus alpha, okay? Where alpha increases with the number of days I've had after my feedback. All right, so all of that is just to get to this point here where my total contribution is going to be a combination of my effect on unmonitored days, which incorporates that probability of being observed. And then I have those unmonitored days, which is going to incorporate the n minus m minus delta, are all those unmonitored days after I've received my feedback. All right, so all I want to do is take this and sort of do some rearranging so we can get to a basic form, okay, where we have some sort of a constant based on y bar, or in other words, the amount of effort I give if there's just a small chance of being observed. Then I have this beta, which is the average effect of any chance of being, or sorry, the average effect of an unmonitored day. And then, the rest is actually fairly straightforward, where I have the effect of being, the effect of probability, and then the effect of receiving feedback. And the point here is just to get us to this, is to say, look, once I've gone through these things and I've assumed a linear effect from this probability, and I've assumed a linear effect from this feedback, I can get to a very basic structure that starts to look a lot like what we're going to use in a regression. And mainly, the biggest point here is I think often people struggle with what I'm doing here by adding up all of those probabilities during your monitored days. So I'm going to take all your monitored days, and I'm just going to keep adding up all the probabilities and use that as a variable potentially. And that gives me the chance of controlling for the intensity of your monitoring. All right, so this brings us to the specification, and it looks a lot bigger than it used to. So we have student K, K as in kid, student K with teacher I in school S and year J, right? So we just have a vector of teacher characteristics, a vector of student characteristics, and these can include, so for the teachers it's going to include experience, potentially some other things like race, but it turns out not to matter. Not matter in the directions of it, or for my purposes. And then we're going to have student characteristics, which again have race, age. It's going to have a few other things. The biggest one there is going to be your previous test scores. So for student characteristics, I can control for their previous year test scores. And then last, we've got a teacher fixed effect and school fixed effects. Notice that teacher fixed effects are identified. I'm able to do this because I observe almost all my teachers in multiple years. Okay. The other thing that's now sort of a little more complicated is I'm going to allow for the effect of unmonitored time to be different based on which window it occurred in, right? So in other words, unmonitored time at the beginning of the school year might have a different effect than unmonitored time right before the tests. And as it says here, I'm just going to make sure, again, I want to emphasize that we're able to control for teacher improvement after their feedback and control for the varying evaluation of threat intensity. And then, of course, I'm again mentioning that this is 4th and 5th graders only. So just as sort of like a visual representation of what that sum of P is, again, if you have one person receive their evaluation early, you have another person receive their evaluation later on, that variable is just taking the sum of all of those daily probabilities. The other thing to understand is that towards the end of the window, the probability of being observed has to grow as there are fewer and fewer teachers left, and also you still need to be evaluated, right? So in other words, if you get to the last day of the window and you haven't been observed, you should be fairly confident that you're going to be observed that next day. And then also this is just a depiction of how the post-feedback days can be identified given the varying times of the evaluations and also variation in the space between the evaluation and when you received your feedback. All right, so first of all, as I mentioned in 2010, so the 2009 to 10 school year, everybody had their first their first window, their first master educator evaluation announced. Okay, so in other words, all of their time during that window would be no threat time or unmonitored time, it should say. But what I want to point out is that many teachers have no unmonitored time. And this is just because of how those windows overlap, but it's entirely possible, and in fact it is true in most cases, that teachers don't have these sort of like days off, these unmonitored days. And the last thing is also, there was a fourth window that could potentially occur after the second principal evaluation before the tests, but that almost never happened because principals did not want to do their third evaluation right before tests. So I'm going to ignore that fourth window. All right, and then here's just sort of the average number of days within each window, so you can have an idea of how big we might think these effects are. But usually for windows 2 and 3, it's going to range between 5 and 10 business days, except in 2012. And so again, remember these are business days, so that's about 1 to 2 weeks of unmonitored time. And then here, to sort of check as best we can whether or not principals were targeting specific teachers or targeting specific students, we can start to look at a balance check. So the outcome here is, I mean, you can do this on a variety of things, but this one's just, the outcome is how many unmonitored days you have from the principal, right? Oh no, this is just unmonitored days in general. So if there were some way that the master educators and the principals are in a sense coordinating, not like explicitly, but potentially coordinating and targeting teachers who are struggling or who have struggling students or something like that, we would expect to see something pop up here where students who had very low scores last year in reading or math, or students who are from low-income households, right? You can imagine that principals and master educators might target those teachers first to give them feedback early. That turns out not to be the case, at least in any sort of identifiable or measurable way. And then, of course, the other thing is they could potentially target teachers. So I am not, mainly because the effects are just so different between veteran teachers and novice teachers, I'm actually going to exclude first-year teachers. But you can imagine, again, they might target teachers who did poorly last year or may have had a low rating last year, so this highly effective or minimally effective. Those are their full-on impact ratings from the year before, and it could be that maybe we're going to go out and target people who did very poorly last year, right? And again, it turns out not to really be at least occurring in a measurable fashion. And I have these overall F tests, which are very much not significant. All right, so again, just to be clear, this is sort of our best way of addressing that problem, but it is not guaranteed, of course, that there wasn't any form of targeting on dimensions that I don't get to see. But at least this is helpful in knowing that these are all the dimensions that usually affect student outcomes, and nothing there is occurring. All right, so here are the basic results. So I've left out any sort of significant stars in preference of these brackets underneath. So these are from 500 randomization inference simulations. And so those are going to be the 95% confidence intervals for the p-value. So as you can tell for that first window, there's very little happening. There's very little going on. So in other words, if you have one more unmonitored day than one of your peers, it doesn't seem to affect your students' test performance in math if that occurred sort of in that first fall part of the school year. Really up until about mid-November. Window 2 has some negative effects eventually popping up. And what I want to point out though, so they're there and they're small-ish. They're about half the size of the effects from window 3, but they're also not terribly consistent, as we'll see in the next slide. But in some cases, they are statistically significant. And just to be clear, sorry, all these different versions, what I've done is I've just introduced, first I start off without any of the probability controls or the post-evaluation feedback controls, just to show that even without those controls, unmonitored time clearly has some sort of an effect in window 3. But then as we add those in, for example, if we start controlling for post-evaluation feedback time, as you would expect, it's sort of pulling out some of the potential positive effects of unmonitored time. And then the probability controls don't seem to adjust much. And these are the results for reading. And again, we have much of the same, at least for window 3, where there are some strong and significant effects. For window 2, things are going in the other direction, but they're very small, even though sometimes they are statistically significant, especially in sort of that final preferred specification. The effects on reading from window 2 are effectively 0. So a lot of the effects that we're seeing in reading are occurring right in that third window in the month and a half or 2 months right before student standardized tests. Now, because tests aren't the only thing we care about, there might be other things happening here that we are interested in. And so I look and see if unmonitored time affects student discipline, so suspensions. So what I've done here is I just add up, for every student, I add up all of their suspensions across the year. And then I try to see if their teacher having more unmonitored time correlates with more suspension days for that student. So this does turn out to be the case in window 3. Students do have more suspension days when their teachers have more unmonitored time. Another way to do this, and I sort of prefer this, would be to try to estimate the probability of a teacher suspending a student on that day. So in other words, for each teacher, I'm going to look at all of her suspensions for each student and try to identify if she, or measure the proportion or predict the probability that she's going to suspend someone on that day, right? And so the point here is that unmonitored days increase her probability of suspending a student by a meaningful amount, okay? So she's about 7% or so more likely to suspend a student on an unmonitored day. Yeah?
So I was trying to think through this. So is the idea that when I'm not being monitored as a teacher, I'm just more likely to suspend a student? So does that mean on a monitored day, like because I'm being evaluated, am I sort of thinking I'm going to try and work more with Johnny to see if I can get him to work for me, or
Yeah, so the story in my head, so first of all, I don't know exactly, but in my head what I would say is, on those days, and this is what we're going to get into in a minute, but what we see is that teachers are shifting dramatically towards teaching to the test in that third window. And so it is not uncommon to see sort of behavioral responses to this, right? Because it's a lot less engaging learning. And so that would be like, in my head, that's what's going on, is that you've just prepared your lesson in a certain way that is not very well tailored to keeping some troublesome students engaged. But again, it's not, it could just be that maybe on a monitored day, I don't want to have half my class missing, but I think it's more just that the way I prepared my class is less conducive to students having good behavior. And part of this is also the evaluation does include measures of how well you've managed your classroom. And so if I'm just sort of shirking off on that, then I'd expect to see some increases in suspensions. All right. So as I said, we see these effects. Students are more likely to be suspended on those days. I apologize if this is a little difficult to read. But these are the 9 different dimensions of the evaluation. And so I've ordered these on the left side here. I've ordered them based on the magnitude, right? And what I did is I broke up that, so the second master educator evaluation perfectly straddles the testing season. So half of them roughly occur before tests, and half of them occur roughly after tests. And so what I wanted to see is if teachers before the test are shifting their teaching in a particular way that's different than how they would shift after the tests. And so again, what I'm doing here is for a teacher who is less likely to be monitored, what does she end up scoring on these different outcomes? So what you can see is that a teacher who is less likely to be monitored, she's going to be less likely to develop higher level understanding. She's less likely to maximize instructional time through pacing and student idleness and behavior controls. She's less likely to engage all of her students in an accessible and challenging way. She's less likely to respond to student understanding, and also lastly, she's less likely to provide multiple ways towards mastery. Notice, of course, that in gray, I've highlighted the ones that we'd expect to be sort of teaching to the test, right? If I'm teaching to the test, these are the things that I'm going to really sort of let go, all right? So again, before the test, teachers are very likely to let those aspects go. But then after the test, there's really no discernible pattern in how teachers are shifting their behavior when they're unmonitored. Now, to be clear, after the test, they are changing their behavior in sort of response to the probability. It's just not, it doesn't have any clear patterns in terms of the dimensions of the evaluation.
A quick clarification question.
Yeah.
The teachers are not observed as the same person before or after, right?
No.
And I know those questions are kind of the pedagogical in purpose, but I'm just really wondering or worried that I teach finance, you send a marketing people to watch my class, and she probably have no clue what I'm talking about. And vice versa, right? So do you think there's a way to control for that? Because there could be a math teacher observing a math teacher before, or a PE teacher watching a math teacher after.
Yeah, so in these grades, teachers are teaching both math and English, right? So it's the same teacher who teaches both subjects. But that's, so your real concern is if the evaluator's coming in and they're like a 7th grade algebra teacher. And the answer is I'm not entirely sure, but I can. Yeah, in fact, I don't even get to see exactly which observers there are for each of these. But I'm just gonna have to rely on the fact that they've been designed in a way to sort of be agnostic of that. But yeah, I don't know if there would be any particular issues there. But yeah, I mean, it seems plausible. Now, as we see, they shift away from these styles, and I've kept the same ones highlighted. So again, the ones in gray are the ones that we think you would let go of as you want to teach to the test. And here is through through an instrumental variables approach, I can try to estimate the causal effect of these different standards on student outcomes. And all I want to point out here is that many of the ones that have a reasonably large positive effect on student outcomes are the ones that teachers are most likely to let go of. And so this is sort of where things start to get a little puzzling, right? Why is it that teachers shift towards some teaching behavior that is less effective than what they should be doing, right? And particularly given the size of the incentive tied to teachers' student test scores. And so there's just a basic idea here, and this isn't something I'm going to be able to test in this setting, but basically the idea may be that teachers have this production uncertainty, where the effect of pedagogically sound teaching on the right here is higher on average, but has a lot of this variation in terms of its marginal effect on student outcomes. Whereas teaching to the test may be less effective on average, but at least its variation is small. And so what this would predict is just that teachers may choose to use something that is less effective on average if the effect of the other one is so uncertain. All right. So we can try to test this even by seeing if the different standards have different effects on student score variation. And so that's what I do here. So again, all these things that teachers are letting go of, so the things that are sort of like the opposite of teaching to the test, the gray ones, they are also the ones that are most likely to contribute to student score variation. So in other words, this is just sort of preliminary evidence that as teachers are prepping up for this test and they're getting very nervous about these high stakes exams, they're trying to manage the risk and the uncertainty by shifting towards teaching to the test, even though on average it may be less effective. And lastly, so another way I can test this is actually there's 1 year where I can see 3rd grade student tests, and the teachers in this grade weren't receiving any of these sort of high-powered incentives. And so I can try to see if maybe in 3rd grade there are these same effects, right? And so that would sort of help me differentiate if it's this high-powered test, sort of this high-powered incentive based on tests that's driving some of this. And as you can see, there's just nothing happening in 3rd grade in terms of that 3rd window. In reading there is some, but it's just noisy. So this isn't foolproof, but it would be sort of indicative that maybe it is the high-powered incentive based on tests that's driving teachers towards this behavior. In the interest of time, I just want to, I've got time. I can do a placebo test, lastly, just some robustness tests. I can look at a placebo where I look at unmonitored time that occurred after the test, right, to see if maybe I'm just picking up on something spurious. And so that's this placebo. The placebo is unmonitored time that occurred after the students have already taken their test. And thankfully, as we'd expect, there's no effect happening there. All right, lastly, in order to deal with the potential that there are these unobserved characteristics that principals and other evaluators are using to target their evaluation timing, we can use this, this procedure suggested, well, originally by, oh man, I can't remember all of their names. But this is essentially trying to measure how much the outcome would have to correlate with unobserved factors that correlate also with the treatment, right? So in other words, essentially, if my number is greater than 1, that means that it's fairly unlikely. In other words, the unobserved characteristics would have to correlate more with the outcome than the things I get to see. So in other words, it'd have to be things outside of previous student test scores, race, income, all these other things that correlate stronger with student outcomes in order for there to really be the possibility for these unobserved things and this unobserved targeting to actually matter. And so thankfully, again, it doesn't look like that's very likely. So just to wrap it up, these changes in teacher behavior when they're unmonitored do increase disciplinary problems and they do reduce student test scores, but it appears most pronounced in the time prior to the test. So this is somewhat in line with a lot of the monitoring literature where monitoring is somewhat better at preventing unwanted behavior than it is at promoting desired behavior, but that's like, it's not a perfect characterization. And that's it. Thanks.